Okay, good morning students. Now in the control system subject, now this session we just see the topic of signal flow graph. Okay, now you already covered the block diagram and block diagram reduction rules and how to solve the block diagram problems. Now we did the signal flow graph. Okay, I just give a small example such that you can easily understand. Now see here. Now you know the block diagram. What is the block diagram? The block diagram is nothing but short and picture representation of a control system or a system between input to output. This is one block diagram. Is it right or not? So far what we are covered is the block diagram. Okay. Now see here. Now this is this is block diagram. A simple block diagram. Now this input variable is treated as one node and this output is treated as another node. Now between these nodes you just connect the line with the direction, and this is the direction, and this is input and this is the output node, and in this particular signal, this direction, and this is the gain. That gain you can take it here in terms of blocks, and this is in the line itself. So this is the block diagram and this is its corresponding signal flow graph. This is the flow between the nodes with the direction with the signals. So that's why this is called as signal flow graph. This is the signal flow graph and this is the block diagram. Okay. So this is a simple way how the block diagrams and how the signal flow graph. Okay, this is a block diagram. You know the rules and regulations of the block diagram and how to solve the problems you already covered. Okay, now we'll see the signal flow graph and how to solve the problems in the signal flow graph. Okay, now all these things we'll see. Okay, so I just take one small signal flow graph between the nodes, and such that I will try to understand the basics of the signal flow graphs and what are the parameters and what are the notations. First we will see, and after that we will solve the problems of signal flow graph. Okay, so let us see here. I just draw a small diagram. So this is the signal flow between the nodes. Okay, now see here, these are the nodes and this is the flow between the nodes. Now we'll try to understand the definitions of this particular signal flow graph. Okay, now first I want to explain input node. What is that? First is input node. What is input node? Now see here, listen carefully. What are the input nodes, or we may also call as input node or source node. Okay, input node or source node. Now see here, input nodes are the nodes which are having only outgoing branches. Okay, what are the input nodes? Input nodes are the nodes which are having only outgoing branches. Now see here, these are the nodes and these are the branches are available, but what are the input nodes? The input nodes you are treated, these nodes comes under the category of input nodes, the nodes which are having only outgoing branches. Now see here, this is incoming branches, this is outgoing branches, and this is also outgoing branches. But what I am saying only outgoing branches. Which nodes are having only outgoing branches? See here, This node is only outgoing branch. This node is also outgoing branches. So the nodes which are having only outgoing branches comes under the category of input nodes or source nodes. Therefore, x1, x2, x3 are input nodes. Next, this is the input node definition or a source nodes definition. Okay. Now the second one is output node or sink node. Output node or sink node. Now see here. What are the output nodes or what are the sink nodes? Output nodes are the nodes which are having only incoming branches. Okay. Output nodes or sink nodes are the nodes which are having only incoming branches. Now see here. This is only incoming branch and this is only incoming branch. The node which is having only incoming branches comes under output nodes or sink nodes. So therefore, this x5 and x3 comes under output nodes or sink nodes. Okay, clear or not? Next one. What is the next one? Mixed node. Okay, mixed node. Now I think you understand the mixed node definition. What is mixed node? Mixed node is a node which is having both incoming and outgoing branches. Which is having both incoming and outgoing branches. Now see here, we want incoming as well as outgoing also. Therefore, this x4 node is a node which is having both incoming branches as well as outgoing branches. Therefore, this x4 node is called as mixed node. Clear or not? So, input nodes are outgoing branches only, output nodes are only incoming branches, and mixed node is having both incoming as well as outgoing branches. Clear or not? Okay, note on this. Loop. Now students, what is loop? Now loop is nothing but which originate and terminate at the same node. Now at which particular node you are started, you go and take a return path and again ended with the same node. Then starting and ending will be at the same node. Now that particular node, that particular thing is called as a loop. Which originate and terminate at the same node is called as a loop. So here I will give a few examples and you can easily understand. And I am giving some valid and invalid loops. You try to understand the valid one and invalid one. So here are the few valid and invalid loops. So you try to identify which one is valid and which one is invalid. Now see here, these are the signal flow between the nodes. Now we'll check one by one, okay? Now this is the, let us assume one node. So here it will start the signal flow and it will not come back and not winding, not ending at the same node, okay, which is not starting and not ending at the same node. So it's not called as a loop. It is not a loop. But you see here, this is one node starting here, go to somewhere, again take a return path and again terminate at the same node. This is called as a loop, which started and ended at the same node. Now see here, this is starting and going to somewhere, but it will not take a return path and not ending at the same node. So it's not a loop. But you see here, starting here, go to somewhere, again take a return path, and this is a loop, starting and ending at the same node. And this is starting and ending at the same node is called as a loop, which originate and terminate at the same node is called as a loop. Okay, note down this. Okay, now see here, next one is non-touching loops. Non-touching loops. If you understand the loop, you can easily understand the non-touching loops also. Now see here, this is one loop, loop L1, this is second loop L2, this is third loop L3. Okay, now you see here, this loop L1 and this loop L2, here it is touching, L2 and L3 here it is touching. These are the touching loops because these two loops are having a common node. These two loops are having a common node. Then what I am asking, I am not asking about the touching loops. I am asking about the non-touching loops. What are the non-touching loops? This L1 and this L3, this loop L1 and this loop L3 are non-touching because these two are the non-touching loops because those two loops are not having a common node. Okay, what are the non-touching loops? Non-touching loops are the loops which does not have a common node. So here L1 and L3 are the non-touching loops. Okay, this loop L1 and this loop L3 are non-touching loops because these two loops are not having a common node. These are having a common node, therefore it is touching loops. These two are having a common node, therefore touching loops. But these two are not having a common node. L1 and L3 does not have a common node, therefore these are the non-touching loops. Okay, note down. Now I'll just take one small example. Now this is the signal flow between the nodes. Now see here, these are the signal flow between the two nodes. Let us assume this is input node. Why you are saying this is input node? And let us assume this is output node. How you can say that this is input node and this is output node? Now you already know the definitions of the input node, output node. Input node is a node which is having only outgoing branches, only outgoing branches. Output node is a node which is having only incoming branches. Understand not? Only incoming branches or only outgoing branches. So this is input node, this is output node. Now this is one signal flow. Now where we are? We are in the identification of forward path. This is the forward path. What is a forward path? Now listen, forward path is a path from input node to output node. Forward path is a direct path from the input node to output node, and that path is not passing through the same node more than one time. What is the meaning of that? Now see here. Now you just identify a path from input node to output node. Now this is one path. I write with a dashed line. You just observe here. This is a path from input node to output node. Identify or not? This is the path from input node to output node. This is one forward path. And some of you are asking, sir, can I write a forward path like this? Okay, you go like this. And you just take a return path here. Return path here. Again, if we go like this, okay, you can able to get the path or not? I just redraw here. So like this, like this. But this is also written. This is also written. Again, I will go like this. Can I take it this as a forward path? Tell me. Can I take it this as a forward path? No, you will never take this as a forward path. Why? Because now see here. Now whatever the path you are taking here, now this path is again passing through this node and again passing through this node, again passing through this node. But that three nodes already passed by some other path. This is the path. So what is the condition? The forward path is a path from input node to output node, and the path is not passing through the same node more than one time. So this path, again you will traveling through the same nodes, same three nodes, which is already covered by some other path. So you are not taking that second path as a forward path. Okay. So this is the wrong path. And this is the only third path. This is the first forward path, right? Now this is the first forward path. This is the first forward path. Okay. Now, is there any other forward path? Now, you just see here, there is another path. Now, this is the input node to output node. Okay. Now, this is the input node to output node. This is another path. Okay. Because that path is not passing through all the nodes. Then this is in a different manner. Okay. Sir, here it is already one time it is okay. Not passing through the more than one time. Okay. Now, this is the second forward path. This is the second forward path. Okay. Now, we understand the forward path, and in this signal flow graph there are two forward paths, right? Right. Now the next one is now forward path gain. Now this is the forward path gain. Now what I am asking? Now I am not asking a forward path. I am asking forward path gain. So now see here. Now, what is the forward path gain? Very simple. So the total gain in that particular forward path. The total gain, whatever the total gain in that particular forward path is called as forward path gain. Now see here. Now this is the first forward path. Now let us assume this is first forward path gain P1. Okay, I just represented with 1 stands for first forward path and this is P1 is a gain of that path. So what is the total gain in that particular forward path? 1 into G1 into G2 into G3 into 1. This is the total gain in this particular forward path. So is called as forward path gain, which is nothing but G1, G2, G3. The total gain in that particular forward path is called as forward path gain. Now this is the total gain in the second forward path. Okay, the total gain in the second forward path is called as a second forward path gain. So let us represent it with P2, second forward path gain, 1 into G4 into 1, which is equal to G4. This is the total gain in the second forward path and this is the total gain in the first forward path. Therefore, first forward path gain and this is the second forward path gain. Clear or not? Okay. Now these are the representations or notations of the signal flow graph: input node or source node or output node or sink node, mixed node, loop, non-touching loops, forward path, total forward path gains. Okay, these are the repetitions while we are solving the problems of signal flow graph. Okay, now one advantage in the signal flow graph compared with the block diagram reduction. Okay, so what is a block diagram reduction? In block diagram, see here, in block diagram we find the transfer function, right? We find transfer function. So we simplify the blocks, use rules and reduction techniques. Okay, we have to remember which rule we have to apply, which reduction technique we have to apply, and we simplify the blocks and we will find the transfer function. Okay, these are the major 3 points in the block diagram. We want to find the transfer function. If you want to find the transfer function, now we use the rules and regulations to simplify the blocks and you can find the transfer function finally. Okay, now this is the approach in the block diagram. So what is the signal flow graph? In signal flow graph, find transfer function, right? So then in signal flow graph we cannot find transfer function, you can find transfer function. Not only transfer function, but also we can find ratios of any two nodes. You can find the ratios of any two nodes. Let us take first node, second node, third node, fourth node, fifth node, sixth node. Understand or not? Total how many nodes? 6 nodes. So you may find 6 node to fifth node ratio, fifth node to fourth node ratio, fourth node to third node ratio, fourth node to first node ratio, second node to first node ratio, sixth node to fifth node ratio, any two nodes ratios. You can find the ratios of any two nodes, or you may find the last node to first node ratio is nothing but what? The last node to the first node ratio is nothing but transfer function. That is the major advantages of signal flow graph. You can find the ratios of any two nodes, any combination. You can take a reverse also, 5 by 6 also. 6 by 5 you can find and you take a reverse 5 by 6. Okay. So this is the advantages of the signal flow graph. We can find the ratios of any two nodes. Okay. That is a major advantage. Here find transfer function, but here we can find ratios of any two nodes, including the transfer function. Now second point you just observed, use rules and reduction techniques. No rules, no reduction techniques. No rules, no reduction techniques. And simplify the block diagram. Here, no need to simplify. No need to simplify the signal flow graph. Whatever the block diagram is given, you cannot keep that block diagram. You apply the rules and regulations of reduction techniques and simplify the blocks and finally find the trans function. But whatever the signal flow graph is given, no need to simplify the signal flow graph. Keep the signal flow graph, whatever the signal flow graph he is given, whatever it may be, a short or large or big or whatever it may be, keep the signal flow graph as it is. No need to simplify the, no need to apply the rules and regulation, no need to simplify, and you can find transfer function but also ratios of any two nodes. Okay, this is a major difference between the signal flow graph and block diagram. Okay, note down this. Okay, so I hope you understand the major difference between block diagram and signal flow graph. Okay, now we'll see the signal flow graph. Sir, how this advantage we are gaining in signal flow graph? Now in signal flow graph, now how can it possible? No need to apply the rules and regulation, no need to simplify the signal flow graph, and how to find the transfer function and how to find the ratios of any two nodes. So there is only one unique formula in the signal flow graph. A scientist called as Mason. A scientist called as Mason. Okay. So he will give one formula in the signal flow graph which is useful to find the transfer function, not only transfer function, ratios of any two nodes. That's why that formula is called as Mason's gain formula. Will able to solve all your needs. So this Mason's gain formula, by using this Mason's gain formula, you can find the transfer function and you can find the ratios of any two nodes. Okay. So what is the Mason's gain formula? What is given? Okay. Now we'll see the Mason's gain formula is the output node 2. Let us take, we'll write like this. Any two nodes, right? So let us take, this is node Y2, node X. Y means whatever you want, X means whatever you want, any two nodes ratio. It may be an output node, it may be input node. If it is output node to input node, then that is called as a transfer function. So node Y2 node X formula is given by Mason is summation k equal to 1 to m p suffix k delta suffix k. Okay. Now let us first, we will identify what is delta. So what is delta? Now this is delta. Delta which is equal to, now 1 minus sum addition, sum of individual loop gains, sum of individual loop gains plus 1 minus sum of individual loop gains plus sum of gain products, sum of gain products of non-touching loops. You know what is the meaning of non-touching and everything. Okay, now see here. Sum of individual loop gains plus sum of gain products of, sum of gain products of two non-touching loops. non-touching loops. Sum of gain products of two non-touching loops. Next, plus sum of alternation minus plus again minus sum of gain products of three non-touching loops. Understand or not? Now, sum of individual loop gains plus sum of gain products of two non-touching loops minus sum of gain products of three non-touching loops. Next, plus sum of gain products of four non-touching minus sum of gain products of five non-touching, and so on. Like that, how many non-touching loops are there in your signal flow graph? Now up to that particular non-touching loops, you will continue the formula. Okay. Suppose in your signal flow graph, sir, there is no two non-touching loops, sir. Only individual loops are available. So you wind up your formula up to this particular point. So there are two non-touching loops. Wind up here. There are three non-touching loops. Closed here. Okay. Like that you can continue. This is the delta formula. Alternation of minus and plus. Alternate minus and plus. Okay. So this is delta. Next, P suffix k. You already know that. What is P suffix k? P suffix k. What is P1? You tell me first. What is P1? P1 is a first forward path gain. What is P2? P2 is a second forward path gain. What is P3? Third forward path gain. The total gain in that particular first forward path, the total gain in the second forward path, or a total gain in the third forward path. Now similarly, P suffix k. What is a P suffix k? P suffix k is nothing but kth forward path gain. The total gain in that particular forward path is called as kth forward path. Okay. So the total gain in the first forward path is first forward path gain, second is second forward path gain. Now k is nothing but kth forward path gain. Okay. The total gain in the kth forward path is called as a kth forward path gain. It may be first forward path, second forward path, whatever it may be. Okay. And next one is delta suffix k. Okay. What is delta suffix k? First, there are two steps here. Okay. While identifying delta suffix k, there are two steps. First step is remove all the loops. Remove the loops which are touching kth forward path. Okay. So let us take this is first forward path. Remove the loops which are touching first forward path. Now let us take this is first forward path. All the loops which are touching to the first forward path, remove. That is the first step. Second step, now apply delta formula for finding delta k. Now, okay, before you apply delta formula for delta k, before that you want to do the first step, which is nothing but remove the loops which are touching that particular path. Okay, very simple. You can easily understand while solving the problem. Now you first note down these formulas. Okay, now already we'll take one small signal flow graph. We'll solve that particular problem. Okay, immediately. Hold on. Now, so we'll take a same signal flow graph and we'll take one question, okay? Now, this is signal flow graph. Find transfer function. Okay? What is the transfer function? Now, transfer function is nothing but output node to input node. Last node to first node ratio is nothing but transfer function. This is one question he is asking. Find transfer function output node to the input node ratio. Okay, but we have one unique formula, a Mason's gain formula. So any node to any node ratio. Okay, now say this is the output node, this is the input node. Now I just explain a few steps. You strictly follow those steps for any signal flow graph. Okay, now once he is asking the question of the signal flow graph, first you find the delta value. Okay, first we want to find delta. What is delta? This is delta formula is available here, delta formula. So if you want to apply the delta formula, if you want to find the delta formula, now you required loops. Okay, so before you find delta, so identify the loops, which means that now the first step one is loops. So I'll write the steps also. Okay, steps. Step one is identify loops. Identify loops. Now identify where are the loops. Okay, now this is one loop, loop 1. This is second loop, loop 2. Okay, and some of the students are thinking that this is one loop. How this is a loop? You tell me. Okay, if there is a reverse path like, yes, we can agree this is a loop, but now here which path? This is the path like this. This is not a loop. Okay, this is not a loop. And one more thing, students are thinking that sir, this is one loop. So your big loop, it should not be a combination of two individual loops. Okay, so this is one big loop, we call it. This big loop is already a combination of this is one loop and this is another loop. Okay, so that individual loops will not form a big loop. Okay, so which means that a big loop, a loop which should not be a combination of individual loops. Okay, so this is not also not treated as a loop. So therefore total how many loops? Loop L1 and loop 2 L2. So identify loops, and step 2 is apply delta. Apply delta formula. So what is delta here? Now this is delta. Delta which is equal to 1 minus sum of individual loop gains. What is the sum of individual loops? L1, L2. L1 plus L2, sum of individual loops, plus 1 minus L1, 1 minus L1 plus L2, sum of individual loop. Is there any other individual loops? No. Next, plus sum of gain products of two non-touching loops. If you see here, L1, L2, two loops are available, but these two are touching. I want non-touching loops. Is there any non-touching loops? There is no non-touching loops. So you close your formula is here. So finally what is delta? See here, what is delta? 1 minus sum of individual loops. What is a loop n? Individual loop gains. L1 gain is minus G2 H2. This is a loop gain. Minus G2 H2. This is the second loop gain. Minus G3 H3. Now, therefore, delta which is equal to 1 plus G2 H2 plus G3 H3. Okay. Now, this is delta formula. Okay, delta is completed. Now, step 3 is Find forward paths. Find forward paths. Okay. Now, what are the forward paths? This is first forward path. This is a second forward path. Okay. So, first find forward paths and find the formula. Now, output node to input node. Output node to input node ratio is delta is here. Now, total how many forward paths? P1 means delta 1 is present plus P2 means delta 2 is present. P1 delta 1 plus P2 delta 2 divided by delta. Now, output node to input node. Output node to input node ratio. This is the output node to input node ratio. Now, this is the forward path P1 delta 1, P2 delta 2. Okay. Now, delta is already calculated. Now, see here, what is P1? The first forward path gain which you already calculated. What is the first forward path gain? This is the first forward path gain. G1, G2, G3. Okay. G1, G2, G3. Once if you find P1, you want to find delta 1. Then I am already saying that delta K is calculated 2 steps for finding the delta K. What is the step? Now, delta 1 means first forward. See this suffix. Okay. So, this is 1. 1 means first forward path. Where is the first forward path? This is the first forward path. Remove the loops which are touching this path. Which loops are touching that path? This loop L1 is touching, remove. This loop L2 is touching, remove. Now, after removing the loops, loop L1 is removed, loop L2 is removed. So, L1 and L2 is removed and you apply the formula of delta. Okay. So, now is there any other loops? After removing these loops, is there any other loops are present in the signal flow graph? No. So, there is no other loops here. Therefore, delta 1 is nothing but 1 or delta K is nothing but 1, which means that now apply the formula 1 minus sum of individual loops. Is there any other individual loops after removing this? No. Therefore, 1 minus 0 which is equal to 1. Next, place P2. What is P2? Second forward path. Okay. Now you just this is L1, this is L2. Now, second forward path is, this is the second forward path which is G4. Now, remove the loops which are touching this path. Okay. Remove the loops which are touching this path. Now, this path is, any other loop is touching this path? Yes. Which loop? This loop is touching. L2 loop is touching. Therefore, this L2 loop is removed. Don't remove all the loops. Remove the loops which are touching only that path. So, this path, this is the second forward path. Now, this path is touching the loop L2. So, L2 loop is only removed. Then, is there any other loops? Yes, there are some other loops. Then you apply the delta K by calculating delta K using a delta formula. Now, 1 minus sum of individual loop. Yes, 1 minus sum of individual loop is here now. 1 minus L1. 1 minus sum of individual loop gains. What is L1? Minus G2 H2. Okay. Now, this is the output node to input node ratio, and this is nothing but transfer function, And what is the question? You can easily answer. For any signal flow graph, you just follow these steps. Identify the loops, apply delta formula, find forward paths, and according to that you continue. Okay, note on this. Okay, now this is one signal flow graph here. Now see here. Okay, so now what he is asking? He is asking to find transfer function again. Okay, now what is the transfer function? Output node to input node ratio. But what is output node here? Output node is represented with C, and input node is only outgoing branches represented with R. So we need to find C by R. Okay, so what I am saying, first identify the loops. What are the loops? This is the loops. Originate and terminate at the same node. Loop L1, loop L2, loop L3. Okay, next step 2. What is step 2? Apply delta formula. Okay, so here this is the delta formula. 1 minus sum of individual loop gains. What is individual loop gains? L1 plus L2 plus L3. Next, plus gain products of two non-touching loops. This loop L1, this loop L2 is touching? No. L2 and L3 is touching? No. L3 and L1 is touching? No. Non-touching loops. What are the non-touching loops? L1, L2, L2, L3, L3, L1. These are the non-touching loops. Sorry, two non-touching loops. Two non-touching loops. Gain products and whose sum of gain products of two non-touching loops. Okay, next one, see here, minus sum of gain products of three non-touching loops. Minus three non-touching loops. Is there any three loops here? Yes, there are three loops. But these three are non-touching? Yes, loop 1, loop 2, loop 3 are non-touching loops. Therefore, L1, L2, L3. Suppose is there any other three non-touching loops like this, L4, L5, L6, and whose sum? But unfortunately here, this is not there. Okay, now up to this particular thing is the formula. Okay, right. Now you just first find delta. What is delta? Delta is nothing but 1 minus sum of loops gain x plus y plus z plus sum of gain products of two non-touching loops xy plus yz plus zx minus now gain products of three non-touching loops x, y, z. This is delta. Okay, delta is completed. Next, find forward paths. But how many forward paths? Only one forward path. This is the only one path and one forward path. Okay, now C by R. What is C by R? Delta is already calculated. Only one path is nothing but P1 delta 1 by delta. P1 delta 1 by delta. What is the first and only one forward path? 2 into 4, 8, 8 into 3, 24 into 1. So 24. Now delta 1, remove the loops which are touching that path. Now this is the path, remove the loops. This loop is removed, this loop is removed, this loop is also removed. All the loops are removed, nothing is available. So now delta 1 or delta k is nothing but 1. 1 minus sum of individual loops, 1 minus 0, which is equal to 1. Therefore, which is nothing but C by R, which is equal to P1 delta 1 by delta, which is equal to 24 by delta. Clear or not? Now this is P1 delta 1 by delta, which is equal to 24 by delta. So this is a C by R formula, and this is the forward path, and this is the signal flow graph. How to find any problem? You can take a number of problems, same procedure without any change. Okay, first identify the loops. You just identify the loops and apply delta formula and find forward paths. Okay, it's over. Okay, note down.